Alright, what's up guys? We're moving on to the exponential equations mini lesson. So these are the types of problems that we can see with exponential equations. Remember, our goal for these ones is to get a common base on both sides of the equation. Then we've got a simple linear equation to solve it from there. So looking at this one, I've already got a base of 2 over here on the right side. I can turn 8 into a base of 2 by remembering that 8 is just 2 to the third power. Alright, so I'll replace 8 with 2 to the third power. Now 8 was being raised to the x, so I got to remember that x. And then I won't mess with the right side because it's kind of how I like it anyways. Simplifying a little bit, I got power to a power, so those get multiplied together. 2 to the 3x power equals 2 to the 5th power. So now that I've simplified a little bit, I've got 2 on both sides as my base, which means that I can set my exponents equal to each other. So 3x equals 5. 3x equals 5. I can divide by 3 on both sides. X equals 5/3. And that's how you solve that problem. Okay, that one's probably one of the easier ones. Here's one that I've already kind of seen has given some people some fits. I'm not going to lie, it's actually a harder one, but it shouldn't be too bad. So looking at this, I got 5 to the x, I've got a 25 to the x over 125. Just going on a limb here, probably want to change things to a base of 5 and make life a little easier. Okay, things to remember here, we got 25 is 5 squared, 125 is 5 cubed. So again, knowing some of those extra powers is kind of helpful. Alright, so I can change things to bases of 5. So 5 to the x. Okay, this will be 5 squared to the x, and then I've got 5 cubed for the bottom. And that one wasn't raised to the x or anything, so we can kind of just leave that one alone. A little bit of simplifying here with my power to a power there. 5 to the 2x all over 5 to the third. Now, here's the part that's given people fits so far that I've noticed. Don't forget your regular exponent rules. We still need to simplify so we have just one base here on the right side. Don't forget your exponent rules. We got things with the same base, one in the numerator, one in the denominator. You subtract the exponents in that case. Alright? If this was just like x to the second power over x to the third power, you just do 2 minus 3. Okay? It's just like that. But it's an expression. 5x equals, this will be 5 to the 2x was the one on top, subtracting from the one on bottom, which was 3. Okay? So we use those exponent rules to actually make a nice little expression right here that we can then use to say, hey, we've got the same base, so we can set our numerators equal to each other, or not, I keep saying numerators, set our exponents equal to each other. So here's our equation that we get from this. We get x equals 2x minus 3. Solving for x, let's see, that would be negative x equals negative 3, so x equals 3. Alright. That one's a little funky. I admit, that one's weird. It's alright. We're there. Now we've got this. This is helping. Okay. Last one that's kind of a similar one to one that we could see later. Taking advantage again, 16 and 32, multiples of 2. 16 is 2 to the 4th power, 32 is 2 to the 5th, so we can rewrite those. We got 2 to the 4th power raised to the x plus 2, and then we've got 2 to the 5th power, and that's all that's going on over there. Alright, simplifying, again we got to multiply these. Just carefully, you're multiplying by the whole expression up there. That's going to be 2 to the 4x plus 8 equals 2 to the 5. Okay, same base. Set those exponents equal to each other. Almost said numerators again. 4x plus 8 equals 5. So we'll do some simplifying. 4x equals negative 3. Divide by 4. X equals negative 3/4. And there we go. There's your crash course in exponential equations. There you go. Have fun.